Topic 8-4, Dividing Radicals. This can be referenced with our whole textbook, Chapter 11, Section 8, starting on page 816. Okay, multiplying radicals. You've got the radical sign, sometimes separated by numerator, denominator, and sometimes put underneath. These radicands are put completely under the radical sign. Notice you can do one of two things. You can look at it and see if it can reduce, which it cannot. This one cannot. So if it doesn't, go ahead and take each one and separate them into a numerator denominator with its own separate radical. You've taken this large radical and separated it into the top and the bottom. Okay, so square root of 3 is already in its simplest form, but square root of 16 can now be simplified to square root of 3, and you know that 16 is a perfect square. 4 times 4 is 16. So that would be your complete answer. Although this one, it was separated, but instead of taking any radicals to its own form, let's put them together. So you're kind of going backwards than what was done in number 1, because we know that 21 divided by 3 is 7. And that is already in its simplest form, so you keep it as a radical 27, square root of 27. Up, I'm saying 27, 7, sorry. Okay, look at number 3. You've got 8 square roots of 48 over 4 square roots of 2. All right, because this is an even number, under the radical and even numbers in the numerator and denominator here, we know we can divide by at least a 2. So think about what can be divided. This actually can be divided by 4. 8 divided by 4 is 2. 48 divided by 2 is 24. So notice how it's shown to be separated, but here they put them completely together underneath the radical so that we could divide. So sometimes it's necessary to look at it as a complete under a radical so that you can use division to simplify it. 24 is actually simplified to 2 square roots of 6. We can show that by knowing that 4 times 6 is the factors of 24, and 4, we're running out of room here, is a perfect square of 2's. I wanted to write the 2 2's so that I could circle them. Remember, 6 is already in its simplest form, so it stays under the radical. The pair of 2's factors completely out, but remember when I can factor out, I have to multiply with what's already on the outside. That's why you have these 2 2's multiplied together to get 4, keeping your square root of 6. Okay, this one is, we've gotten to a point where we are rationalizing. I'll put rationalize the denominator. Alright, I'll try to explain this, and we need to do several problems to explain it even further, but what you do not want in an answer is a radical in the denominator. So you rationalize the denominator because you do not want answers to have a square root sign in the denominator. So make note of that the reason we're doing this operation right here, and I'm going to highlight this, this is multiplying by a power of 1. If you'll think about square root of 2 over square root of 2, any number over itself really is just 1. So you're really only multiplying 12 divided by square root of 2 like by 1. So all we're really doing is changing the look of this, and that is because square root of 2 times square root of 2 is square root of 4, which is 2. So we've rationalized the denominator by getting rid of the radical in the denominator. But you've got to make sure that what you've multiplied here and here also have to be multiplied in your numerators. So 12 square roots of 2 would just stay this way. But because this is division, you can look at this as 12 divided by 2. So this factors to the 6 that we got here. So make sure you study this one closely. We're going to do some more rationalizing the denominator. All right. The square root of 3 over square root of 7. Notice this one, if you separate it, you have two prime numbers that would stay radicals. They are already in its simplest form. But we want to rationalize the denominator, so again we're going to multiply by a product of 1. I'm going to keep highlighting our products of 1. What I've done here is this is really just saying this times 1. But we know that square root of 7 times square root of 7 is a square root of 49, which is 7. Multiplying square root of 3 times square root of 7 is square root of 21. So this is actually your final answer for that one. Okay, this one's already in prime numbers as well, so you might want to put this in a parenthesis. Our powers of 1, anything over itself. Square root of 11 times square root of 11 is square root of 121, which is 11. We've rationalized the denominator on 4, 5, and 6. I'll just put, that's what you got to know when I say have you rationalized the denominator. So this becomes 11. We have no radical in the denominator, but multiplying square root of 5 times square root of 11 give you square root of 55. So go and try to answer some of the assignment questions on topic Unit 8-4.